All right. EJ Daigle, Dean of Robotics and Manufacturing here at Dunwoody College. I got a short lesson here to introduce you to SCARA robotics, specifically using the Epson T3 SCARA robot. So anytime we talk robotics, the first thing I like to do is go over some of the operating safety rules. First and foremost, kind of did a magic number there. All right. First and foremost, number one, anytime we're using a physical robot, today it's not as important because we'll be using a simulator only, but the operating area should always be clear of personnel prior to running the robot, whether that's jogging the robot, running it in automatic mode. We want to make sure the area is clear. What goes hand in hand with that is that only one person should be operating the robot at any time. This prevents any confusion. If I'm working on the end of arm tool, I really should have that robot locked out and nobody else in the area. If I have two people working, the problem is somebody might be getting ready to jog it, another person, hey, wait to start it, and they think you said start it, and all of a sudden so just to get rid of any confusion, only one person working on the robot at any time. Number three, there's several pinch points that exist. We talk about collaborative robots and all kinds of different things, and robots can be collaborative and we can work alongside robots, but we want to maintain a safe distance. If you're looking at a robot arm, let's say, and it's something like this, and it's got some sort of end of arm tool out here that does something like this. This little pinch point here, you put your hand in here, and as the robot arm comes together, it could easily, for sure, pinch a finger, and depending on the style of the robot, could actually remove a finger. So we want to maintain a safe distance from those locations while operating. It's very important that the emergency stop push button is within reach of the operator at all times, and whether that's somebody jogging the robot with a teach pendant, somebody jogging the robot with a computer, it doesn't make a difference. We want to make sure that emergency stop is within reach of the operator, or for that matter, somebody hitting cycle start and running the robot in automatic mode. Just make sure that robot emergency stop is within reach. Always want to de-energize and lock out the robot prior to any maintenance. That's true for any automation equipment. And then last but not least, specific to the SCARA robot, which we're talking about today, the SCARA robot has an orange light on the top of it. That orange light means that the robot is currently executing its program. Even though the robot may not be moving, it may be in some sort of wait position. It could be a timed wait. It could be an event-based wait. Whatever that is, that orange light means I am ready to move. And you should assume that robot can and will move without any warning. So we want to stay clear, especially when that orange light is on. All right, these are our two styles of industrial robots. The one on the top here, and I do want to go over this definition of robot before I get too deep here. What is a robot? A robot's a programmable multifunction manipulator designed to move materials, parts, and tools and special devices through a sequence of motion in the performance of some task. So people have asked me, well, is a CNC machine a robot? Well, a CNC machine's a CNC. Maybe under the broad umbrella of the category of robot, I would consider a CNC machine a robot. Traditionally, this is kind of what we think about when we think about robots. We see these in the car commercials with welders welding car frames on assembly lines. That's kind of what we think about, but there's several versions of robots. Auto-guided vehicles are robots, and SCARA robots, and articulated arms, and I'd even throw that CNC machine in there as an example. So a SCARA robot, the one up here, it stands for Selective Compliance Assembly Robot Arm. What that means is this is a 4-axis robot. There's an axis here, axis 1, 2, 3 goes up and down, and then 4 rotates around the end of arm tool here. It really can only work off of a work surface here, meaning it's going to go up and down, grab a part here and place it here, grab a different part here and place it here. What it can't do is it can't, reach up into the air. It can't, go sideways. It really can go up and down, up and down. If you've got components in a bin over here, and you need to place those components on a circuit board, let's say, it can go in and pick those components out and place them on the board. And the beauty, so there's some questions on the lab today about kind of the pros and cons. The SCARA robot, it's very fast. It's very accurate. So some pros and cons. I mean, if you're talking about placing components on a circuit board, it's very good at that type of activity. Some of the maybe cons, it's a lower payload. That means it isn't going to pick up a 10-pound part. The other thing that it also is maybe not as good at is it's got a limited reach. The reach is very limited, meaning I can go up and down and I can only swing in the arc of what this robot can do. The 6-axis robot, by contrast here, and we use the FANUC robot, which stands for Fuji Automated Numeric Control. The FANUC robot is what we call 6-axis articulated arms. So you're going to see a lot more axes, a lot more joints. You can see I can go this way, I can go this way, I can go this way. Now I get out towards the end of arm tool, I can go this, I can squeeze the end of arm tool. I mean, I can go all kinds of different directions right here, right? So I get 6 axes of manipulation. So when it comes to things like welding, I can get into some tight positions and hold that torch at a certain angle. So what are some of the the benefits of the 6-axis? Well, some benefits would be we get higher payloads with the 6-axis. So we can get big 6-axis robots that do palletizing routine, or 4-axis for palletizers, but even 6-axis for palletizing. That might lift hundreds of kilograms even is a possibility. We get extended reach. So the same things that were kind of the cons up here are now the pros down here. And then I would tell you the same thing about what the pros were up here. 6-axis robot is extremely fast. I would tell you it might not be quite as fast as in a small work environment as what the Epson SCARA robot is. So it might be a little less accurate. And again, I don't want to discount the speed, but the speed may be a little bit limited if I'm comparing the same activities with these two robots. So just keep that in the back of your mind. All right, so the first thing we need to do is we need to verify your software. So in order to use the simulator that we're going to do today, I want you to go to your Start menu, scroll down, make sure you have the Epson RC Plus folder, and then you should have the Epson RC Plus 7.0 software. So this would be a good time to maybe pause the video, go and just make sure you have this software, and then get the video running again. All right, so hopefully you've gone in and you've determined that you do have this software and that you guys are ready to run. So let's talk a little bit about the robot in general before we actually start programming it. The T3 that we use is model number T3 401S. T3 in and of itself defines the payload. That 3 means it's a 3 kilogram payload versus there is a 6 kilogram called a T6. The 40 corresponds to the arm length of 400 millimeters. When I say the arm length, that's this length right here. So that does define some of the qualities of reach of this robot. So that particular arm is 400 millimeters, the one we use. The 1 on 401 stands for 150 millimeter J3 stroke. This is J3 stroke right here. You'll see that this lead screw essentially takes this end of arm tool down towards the work surface. And so the amount that this screw can go down is 150 millimeters. And then we also have our standard work environment. For the T3 401, we only have an S. We don't have a hazardous environment or a collaborative environment or anything like that. We only have the S as our options there. Let me delete some of this stuff here real quick. Boom, boom, boom. All right, looking good. All right, then let's talk about the axis of movements, or the axes of movements. So J1 is actually rotation here. So you'll see J1 rotating. That's actually rotating on this axis right here, rotating back and forth. So that's the inside part of this arm going with the base back and forth. J2 is, they define it right here. But again, that's going to go all the way down, and that allows this head to swivel on the other end of the arm. So I kind of get two pieces on that arm that I can rotate on, which allows me to maybe be, turning this one all the way this way, and this one could be all the way that way. So we will sometimes call this lefty and righty, depending on the orientation of the arm to the actual head. J3 is the actual up and down movement of this shaft. So again, it goes back to that 150 millimeters of travel. which is based on the length of this rod, but the ability for this shaft to go down towards the work surface. And then J4 is the rotation of that shaft, the ability for that shaft to spin. So imagine if I've got an end of arm tool sticking off this shaft, I may want to be able to rotate that tool, not just go down with it, but also rotate it around that axis as well. All right, a little bit about the programming language before we dabble into the software here. Spell Plus is a basic light programming language that runs in the robot controller. Spell Plus supports multitasking, motion, I/O control. It supports some things like you see here, like for next loops, do while loops, if-then statements. So we can do both looping and conditional statements. Anything that you would expect in a some derivative of the basic programming language, you're going to be able to do in Spell Plus. And we can work with different data types, both integers and some real numbers as well. So a lot of qualities that we get in Spell Plus. The Epson RC Plus software environment looks like this. So we'll actually be able to simulate everything that you guys will be able to pause it and set up your robot and get it working exact same way as what I'm going to have mine working here in just a second. All right, so let's get into the Spell Plus demo. Step 1, create a new program. There's actually going to be a little bit more to it than just that. My robot's been set up for a while, so I actually went in and deleted a bunch of my stuff today just to try to make my software similar to the first time I opened it, because I realize you guys are opening the Epson software for the first time. So I'm going to scroll down, find my Epson folder, and there it is. And then Epson RC Plus 7.0. And there we go. And what I'm going to do first and foremost is help you to set up your robot. When you first come in here, you're going to come into something that looks like this. You may or may not be able to set up a new file or a new project. Don't worry about that yet. There's a couple of things that we're going to do. The first thing I want you to do is under connection here, where it says offline, I want you to change that to say CAD to point. That's the first thing. What that's doing is that's telling our controller that we are not going to be talking to via USB to our robot. We're not going to be using any of these samples. We're not going to be doing offline. We're actually going to be doing CAD to point. So we're going to work in a simulated CAD environment with a simulated robot. All right. The next thing I want you to do is I want you to go to Project, and I want you to go to New, and we can give the project a name. You could call it Main or something like that. And under Template, pick place 1-to-1. All right, pick place 1-to-1. These are palletizing routines. We're just going to do pick place 1-to-1, and we're going to go ahead and hit OK. Now what that's going to do is it's going to give me some sample code. We're going to not use any of that sample code. We'll end up deleting it. But what I do like about that sample code is it does give you kind of a, maybe we will use some of this. Some of this is already here for us, so we might as well use a little bit of it. We'll use that as kind of our structure to write our code. You can kind of see how that works. And then the next thing that we need to do is we need to go to Setup. And we need to go to System Configuration, Controller. We need to go to Robots. Now, when you go into Robots, if there's a robot in here, you're going to need to go to that robot, right-click, and delete that robot. Odds are when you click on that robot, it's going to show you that it's a 6-axis robot. We don't want a 6-axis robot. So if there's a robot in there, you may have to click on that robot and then hit the delete button. I will tell you it will take a minute or so for it to go through and delete the existing robot. And then once you have no robots in here, you can see it says there are currently no robots in the system. Then you can click on Add. And the reason why we want to add is we want to make sure we get the right robot is what we want to do. So robot name, I'm just going to call this Robot 1. It is possible that you could have multiple robots. I will tell you when it comes to the serial number, this actually kicked my butt for a little bit. I had been operating on the software for several years and went in and deleted my robot today. And then I said, uh-oh, I don't have the serial number. I'm not on campus right now. I don't have the serial number. But then I realized after talking to one of my fellow instructors, this number is arbitrary. So you can type in 0001. Motion system will be standard. This is where you could pick up a 6-axis or a SCARA robot. We want to make sure we have SCARA selected right now. The number of joints is 4. The series is T3, and we know that we've got the T3 401S, which is the only one available under our T3. And you'll notice it does show my maximum payload at 3 kilograms. It shows my J1 plus J2 length at 400 millimeters and my Z length at 150. We talked about those in the previous slides. I'm going to hit OK. It's going to build that controller. I will tell you this part, just like the deleting of the controller, the restarting or the building of a controller, will take a minute, and that's no big deal. We'll wait here. Give it a few seconds here. I like it. So now we can see a picture of our robot. We might even be able to drill into here. You can look at the model, the configuration. You can look at all this stuff, the serial number. We're good to go. Now we're going to go ahead and hit close. Project in controller is Epson T3 is not the same as current project. Project in controller will be overwritten, sure. I will tell you, anytime you're using this software, if your computer says, hey, I'm going to, do you want me to allow Epson to make these changes? Yes, give it the affirmative action. If it says, hey, oh, by the way, you're changing the controller, are you sure? Yes, I'm sure. We set it up. This is what we want to do. All right. Now what you're going to see is underneath your program files, I've got this main file that I had in here. And I've also got a, probably in here you'll see a robot points file too. And I don't know what yours will be called. You may have to create a new one if there isn't one in there. But there should be one that says robot points as well. All right. And we're going to start writing some very, very simple code. And I'm going to use kind of the demo as to what they did here. You'll notice that these green little tick marks, little single quotation, I'm going to use that as my program level comments is what I'll call it. I'm going to call this an Epson T3 demo. Oop, I should spell Epson with an E maybe. T3 demo. Put another little quotation, and I will call this IENG. I won't do that. I'll just call it offline programming example. And maybe in here I'll put my name. The thing that you try to do, and then the date, with the kind of what I'd call the program level comments, is we're trying to give somebody information. So if they're wondering, what is this program for? Oh, I see it's an Epson T3. It's just an offline programming example, and EJ wrote it on 410. But it could be, this is our, pacemaker circuit board assembly line 1. And the last person to write it was, Joe on 410, revision 6 or something, right? All right. Now I'm gonna just delete some of this stuff for right now, and tell you that we basically have 2 functions in here. We have function main, and we have function init robot. The init robot, we're just going to use the one that they have in here already. I like it, and we'll just talk about what these different things do. This reset will actually reset the servos. So it resets the motors. This will turn the motors on. So this will energize the motors. So it'll look and say, are the motors on? If they're not, turn them on. Power, this is my highest torque is what I would call this. High torque. So what does that mean? What that means is if this were to run into something, it's going to hit it pretty hard, versus if I go low, the crash will be a little bit lighter. So it's how much force do you want this robot to have? And there is a reason to have more force, right? If we're trying to plug something into a board, we may have to press a little bit harder than if we're just trying to set something down, right? So it's not necessarily about safety, although safety is affected by the amount of torque or the amount of force. This will be my speed. This is how fast the robot moves from location to location. And this is both acceleration and deceleration. So this is accel, comma, decel. So as you're looking at these These are percentages. I can run at 100% speed, I can run at 100% acceleration, 100% deceleration. Stop on a dime, or I come to a slower stop. I kind of ramp down to a stop. So this function init robot, we're always going to call this function, but we're going to call it from our main code. So the first thing that I would do in my main code is I would call init robot. What that means is I'm always going to execute the code in main, and I'm always going to start right here. And I'm going to execute left to right, top to bottom. The first thing I come to is a function call, init robot. That's going to draw me out of my main function into the init robot function and do all of these things that we just talked about. Basically, kind of like a safe line is to your CNC machine. This is kind of our safe line for the robot. Reset the things, set everything where you want it to be, and then when you get down to the end of the function end, you're going to go back up to the next line of code, which will be right here. Now this is where we've got to come up with a program now. What do we want to do for a program? All right. So what I will say is I'm going to do something called a do while loop. This is the most simple loop instruction in the world. We call it do, and then we're going to wait, and I'll say wait 0.1. And when you typed in wait there, that was kind of cool. If you look here, it actually tries to help you. It says wait, I hit space, and it says you can put in a time as a double. So I'm waiting 0.1 seconds. And then I'm going to go to 0.1. I'm going to call it 0.0. All right. And then when I get down here, I'm going to loop back up and go back to the top. So I could do as many of these as I wanted, right? I could say wait, 0.1, go 0.1. I could say wait 5, go 0.2. And you can see how this works. It's basic. And then when I get to loop, I'm just going to go back up to the top. I'm going to do these things all over again. So I'm going to hit 3 points. Now let's talk about what a point is. So very similar to CNC machining, a point is a location in XYZ coordinate space, right? It's the same thing for a robot. We have an XYZ coordinate system, and we need to go to those locations, but we need to define what those locations are. And this doesn't do that. This program just sends me to the point. Something else is going to define those positions. Robot points. So if I go down to, so right now I'm in program files and I'm in main program. If I go to robot points and then go into robot 1, I've got points in here. Now let me get rid of the pick and place points that are in here right now and just delete those. Those are what came in with my software that my template that I brought in. And we have nothing in here now, right? So let's figure out how we're going to know where we want to go into space. So this is where we want to go into our simulator. So right here, if you go across the top and you mouse over, you also can hit Control F5. If I click on this simulator key, you're going to get a model of this robot. This is the part that I really like about this software. This software is really, really cool in that I get a model of the precise robot. And what I'm going to do first and foremost is on my 2D layout, I'm going to delete these things because you guys don't have those in there probably right now. I'll hit right click delete. Yes. Apparently I should have done these before, but that's okay. You guys are getting to see this. Remember what we have is we have two different views here. We have a 2D view and a 3D view. So the 2D view allows me to do some layout work. The 3D view is actually where we're going to program the robot. So the 2D view, what I want you to do right now is go to the 2D view, grab this box feature, and I want you to maybe make that a little bit longer, maybe a little bit wider. Let's make it like a 3x1. And when you do the homework for this week, I will tell you, you will have to create boxes like I have them drawn in the homework. But I want to make sure I'm within kind of the reach of that robot, right? That robot's going to swing around. So I want to make sure I can reach that box with the robot, the yellow signifying where that robot is. So I'm just going to draw a box that's kind of 3 squares long by 1 square tall. And then once I've got that box drawn in there, I'm going to go to the 3D view. And now I can see that box. And if I kind of drag down, I can see that box is definitely within the reach of that robot. And I can see that box lines up with those 3x1 squares, right? So that's something you will have to do. It'll be a different layout for the homework this week, but I'm confident you guys will be able to figure it out. Now what we're going to do is we're going to go ahead and make this robot do something. All right, so I'm going to try to find a manipulating window. Maybe I just want to be able to go from here over to here. All right, so what I'm going to do is there's a tool up here called Robot Jog. It says Object Rotation / Robot Jog. So what we're going to do is we're going to click on this, and we're going to, as we mouse over the different joints, so you've got J1, 2, 3, 4. What I want to do is I want to be able to click on that joint, and then I want to be able to drag that joint to whatever location I want to go to. So maybe I want to go to, like here or something like that, right? I don't know. And maybe I want to actually, let me position myself a little bit different here. There we go. Yeah, I can also move this joint too, right? So let's see where I'm at there. I'm kind of over the middle of that box. Looks pretty good. Centered on it pretty good. I like it. The next thing I'm going to do is I'm going to grab this joint and go down. Now you'll notice if I go down too far, it turned red. That says it crashed is what it just did. So I don't want to crash, so it's going to stay in crashed mode until I hit this little reset collision. And now I want to zoom in on this and try to see if I can get really close without crashing. Where I can go to the point where I'm crashing and then maybe go up just a hair. Let's see if that's enough. That might not be enough. Not quite. A little bit more. A little bit touchy there. All right, one more up. I think what I'll do is I'll move in a little bit tighter here. There we go. Is that good? Not quite. That's probably good. Oh. It's one little tick up. Oh, come on now. Very, I think my mouse is a little bit finicky today here, not more than anything. Let me grab it from the bottom here. Yeah, we'll call that good. All right. So now I basically am going to define this as a point. So you can kind of see how you can move all the different joints around, right? I can move this. I can move that that up, down. I really don't have any reason to rotate, but I could also rotate on J4. You can see this is calling J3 and J4. J3 is going up and down. J4 would actually be rotation. Without me having any end of arm tool to rotate, it doesn't really make a lot of sense in this point. And then J1 kind of does here, and then J2 right here, right? So I think I'm over the middle of that box. I feel pretty good about it. So I'm going to go to this points menu right here. I'm going to teach a point. Click. And it says, oh, you're going to teach a point? Sounds good. We'll call it P0 for you. I'm going to hit teach. Yep. Then I'm going to go ahead and drag that robot around. I'm not going to move the Z-axis. I'm going to leave J3 where it's at, and I'll show you why here in a minute. I'll go back to robot jog. I'll jog this to the other side. Might have to move over a little bit. And maybe I'll even jog it a little further and show you that we can actually rotate this head, right? All the way over to here to try to hit the center of that box over here somewhere now. Something like that. Kind of rotate around, see if it looks good. And people will get finicky about this. They'll say, oh my gosh, I don't know if I'm in the right spot or not. Get close, and I'll show you why in a minute. So I'm going to go ahead and teach that point. And that'll be called P1, right? And now this is the time where I would want to go to my points menu over here. Double click, and I can see the XYZ locations of my points. Now if you go back to your simulator, where are the X's and the Y's? Let me zoom out a little bit here. Okay, your X's and Y's and Z's, right? I have X in this direction and I have Y in this direction. So I really want the Y to be the same value, whether I'm on that X or this X. So when I go into my points menu, I can actually say, you know what, I want the y to be the same. I can see they're both about 300, so maybe I want to do them both at, 305 or something. That's something in between the two of them, right? I will tell you this works fine as long as you aren't making drastic changes. So you wouldn't want to change that 308 to something like 108. It may or may not work, but you got to realize that's coordinating with your X's and Z's, right? So depending on what you're doing, that probably doesn't make sense, but tweaking it a little bit is not a big deal. And I might even say, oh, well, I wanted this to be 250 and I want this to be negative 120. So little tweaks like that usually aren't going to cause you a problem. You'll know if they do, I can promise you that. And this is where I could also tweak in that Z. So I could make that Z a little bit higher, a little bit lower, right? Without having to try to manually manipulate the Z that you saw struggling with my mouse. I got a new mouse and it struggled, but I could make that Z whatever I wanted to right now. All right, so now what I'm going to do is I'm going to go back and look at my simulator. That looks really good. And what I'm going to do is I'm going to go to the run window. Run window. Main program is the same name as the project name. Project cannot be built. Rename the file or the project. Okay, so I can probably rename main. Really easy. And I'll call this, I'll get really fancy here. Ready? I'm going to call this main 1. You could name it whatever you wanted. It could be named lab 1. SCARA lab 1 if you wanted to, right? Let's go back into the run window again here. And it will try to tell you when things are wrong, so just pay attention. Now I've got some build errors here. Let's see here. Main 1, program 1, line 11, point is not specified. Oh, good call. So what you'll notice here is two things. We're not quite yet ready to run, are we? The first thing is we say wait, go to point 0. Now when we go to our points menu here, nothing is defined as point 0. This is just labeled number 0. So I want to call this what I called it in my main code. Computers are very finicky, right? They want to be called go to point 0, then you better have something called point 0 and something called point 1. And for that matter, in my main, I right now in my main do not have a point 2, do I? So I probably want to just get rid of that point 2 just for testing purposes right now and call that good. Now I'll go to run window, and now it built with no compile errors. I can start my program, ready to start. I can minimize that window, can go back to my my simulator view, and what you'll notice is what we had was we had a half-second wait from the one side. Let me move this down a little bit. Then we had a 5-second wait on the one side. So we'll go over to the far corner here for point 1, and then 1 1000, 2 1000, 3 1000, 4 1000, 5 1000, and then we'll go back. So if I want to change that, all I would have to do then is stop my code, go into the main, and maybe I want to wait 0.5 on both of them, right? So let's wait 0.5 when we first start up. And let's wait 0.5 on the next one. And then let's wait 0.5 on this one. And maybe we do want to go to a 0.2. So let's go to a 0.2. 0.2. And we'll call that good. And let's go ahead and define a 0.2 in our simulator. So now in my simulator, I need to move to a 0.2. So I'm going to go ahead and jog my robot to a midpoint somewhere that I think is maybe right about there, pretty close, right? Maybe I need to jog this in a little bit and this back a little bit. The beauty of this again is it's hard to manipulate it, right? I mean, I only have so much control with my mouse. But I'm going to go ahead and tag that as a point. P2 is what they're calling it. Yep, I'll call that good. And then when I go into my points menu is where I can actually define what is the real deal here, right? Well, I know I want my Y to be 305. I didn't want to change that. I still want it to be in the same Y. And then maybe I want to know what the difference between those two is, right? So I know that 250 plus 120 is my number here. And if I divide that by, let's see, divide that by 2, 185, where are we at here? So probably, if I went 250 that way and I went 120 that way, I definitely am going to be in the, so 185 would be 120 plus 65, right? That's where I want to be. Had to do some deep math there to figure that out, but to me that's halfway in between 120 and 250. And then I'll call this 0.2. Hit enter. I can hit save all. When you hit save all, it saves your point files, it saves your main code, saves everything. I can go to run window. Oops, that was not good. Oh, there we go. Hit the wrong button there. Run window. I tried to test auto mode there. That didn't work out real good for me there. Go to start. Go back to my my main section of code here. Now I've decreased those wait times, so it's a little bit more interesting to look at. You can see it's visiting each of those 3 locations. Now I want to do one more thing, and then you guys will get a chance to kind of play. But the other thing I want to do is there's other commands that you guys are going to research for me. So right now we're using a go, and I'm going to let you guys look up and determine what the difference between a go and a jump is. But if you go in here and instead of going to go, if you go to jump and you go to jump and you go to jump, here's what I want you to note when I go to jump. What happens? What's the difference between that movement? So for the lab this week, you guys will have to define, there's about 4 different ones that you'll have to work with. But I'm going to save this, and then we're going to go to the run window, and we're going to watch what this does in jump. Sure it works. Looks like we're running. Now, if you remember what Go did was, Go just moved from one location to the next, and the Z didn't go up. What jump does is it says, oh, you defined where you want me to go. What I'm going to do is I'm going to take Z all the way up in between. So I'm going to jump up and over, which means I don't have to program that up position on J3. I can just call a jump, and as long as I've programmed the lower position, it will jump back up and over every time it moves around. So really, really cool stuff to think about with this. All right, I'm going to show you one other thing in the Robot Manager, which is right here. You may at times run into some point where it says you're out of range or out of limits. And in that case, we can change these values. I don't think we're going to run into any issues, but if it ever says you're out of range or out of limits, these ranges can be changed. So they can become really big negative and really big positive numbers. And the limits can be changed as well for the millimeters. That's going to matter a lot more when we're dealing with the real robot, but it shouldn't matter as much in the simulation. But if you come into something with a limit or exceeds a limit or something like that, some of this stuff may take care of it, a negative to a positive, and the same with these ranges, big negatives to big positives, and so on and so forth. The other thing I want to make mention to you is when you hand in your homework this week, one of the things that I'm going to ask you to do is, if I click on this, is I'm going to ask you to obviously send me the completed Word document with all the questions answered. And then I want a notepad file. You cannot send me the program file. It will not work. It'll actually be flagged by antivirus software because it appears to be an executable. So I want your main program as a notepad file. So all you have to do is click on Notepad, right? Open up Notepad, and then go into your software and grab all of that code, copy, paste it into Notepad, file save as, you can call it SCARA Lab 1 or whatever you want to do, SCARA Lab 1, and then send that off to me, email that off to me. But I also want, before you email that off to me, I also want your robot points because I need to be able to verify that your code actually works. So I also need your robot points. The way you'll do the robot points, very similarly, you'll open up an Excel file, just a blank Excel file, and you'll go into your robot points right here, and you're just going to grab all of these pieces right here, however many there are. Oop, you can just actually do it like this, just grab from here. However many there are, just grab them, copy. You can just hit Control-C, and then go into Excel and paste those points into here. I'm not going to concern myself with a lot of the stuff over here. That's not going to matter as much to me. You know, I probably do want to know if it's lefty or righty on the hand. So you may want to include, you know, in the column over here, lefty, and then just show me that it's lefty all the way down, or change it over to righty. But I need you then to save this file as well as an Excel file for SCARA Lab 3. So that way when you turn in this document to me, what you're actually turning in are three things: your Word document with all the questions answered, the Notepad file with your program, and the Excel file with your points. What that's going to allow me to do is that's going to allow me to paste those back into my simulator and test your particular software. All right, the other thing, when we go into this lab for this week, let me see if I can pull this up real quick here. SCARA 1. All right, when we go into the lab for this week, so you'll have to just describe the two main categories of industrial robots, and we did this in the video, 2 pros and 2 cons. Define all of these. I will tell you the Spell Plus programming language manual that I have a link to right here for the homework. You can look all of those individual things up, and you'll have to define, you know, I will probably put jump and pass and some of those other things in there. I think I'll change that a little bit before I send this off to you guys. Then the lab activity, using the 2D layout tools, you're going to create 3 boxes. You don't have to label them A, B, and C or assembly. That's just for me to show you. And I have an end of arm tool on here, but you don't have to have an end of arm tool on here as well. Basically, you're going to visit cell A, go to assembly, then visit cell B, go to assembly, visit cell C, go to assembly, and then wait 5 seconds above cell C, then go cell C, assembly, cell B, assembly, cell A, assembly, then wait 10 seconds above cell A, and then loop back around and let it continue to run. So I'm going to paste your points and your program into a simulator where I have this pre-built, and you can tell where you're going to have to use the 2D layout tools to build a 3x1 box and 3 1x1 boxes to create this. And you can see where they're at on the grid there. They don't have to be perfect, but they do need to be close. And then again, email me, save the following files and email to your instructor, not just the Notepad file, but the Word file with all questions completed. The Notepad file and the Excel file all need to be emailed over to me. And as usual, let me just make sure I did all this stuff. So we created a new program. We talked about the function main, the init. We jogged the robot, taught the points. We ran. We talked a little bit about the encoders and limits. I don't anticipate those are going to be a problem for you. But what I will tell you is, as you're working through this lab, if you have any questions, any concerns at all with what's going on, do not hesitate to reach out to me. I hope you enjoyed. I hope you have a little bit of fun with it. Again, get a hold of me if you have any questions. Thanks.